So on this question, it says, are couples that live together before they get married more likely to end up divorced within 5 years of marriage compared to couples that live apart before they get married? So that's the question. So couples that live together first, are they more likely to get divorced than couples who don't live together, live apart before they get married? How do you answer those kinds of questions? So this is a interesting question. I think society, this is one of, millions of psychology, sociology kind of questions. How do you answer, with data, not just with opinions, but with hard, fast data? Does it make a difference whether you live together before marriage or not? Does it make it better, worse, more likely, less likely that you're going to end up divorced? How do we do that? So this is a question that has two groups. Do you notice right away? There's two groups. What do I mean, two groups? There's the first group is those who live together, couples that live together before they get married. And the second group is those who do not live together before they get married. And the question is, how's the divorce rates compare for these two groups? Is one higher than the other? Or are they about the same? It makes no difference? Or, what's the story? So we're going to let data inform us. So here's what they did. 204 of the 673 couples from the study who lived together, that's the first group, before they got married, were divorced within 5 years. So for the first group, 204 out of 670, it's like about a third to a fourth, something like that, got divorced. And then 109 of 454, that's maybe a fourth or a fifth of couples from the study who lived apart before they got married were divorced within 5 years. What can we conclude? So the question is there statistical evidence? Is there data, not just opinions, but statistical evidence to say that one way or the other way is better, living together beforehand or not living together? Which one tends to have less divorces? That's what we're looking at. So whenever you're doing two groups, come down. The first question is, what kind of study should we use? Well, we're going to want to choose this one right here. It's a z-test for the difference between two population proportions. So the key there is proportions. Everything we do is either percentages or averages. So this one is percentages because how do I know it's percentages? Well, when they say 204 of 673, that's telling you a part of the group, right? 204 out of 673, and then 109 out of 454. That's a part of the group. So a proportion is a part of the group. So whenever they're giving you parts of groups, that's proportions or percentages. And notice there's nothing here about average or mean anywhere. So it's two groups and their proportions. So we're choosing two proportions. All right, here we go. What's HO? Well, we're going to do P1 and P2 because now we have two groups. And this is equals always, right? HO is always equals. And then what about H1? Well, it's going to be P1, P2. Now it's either greater or it's less or it's not equals, right? It can't be the same thing. It can't be equals again because then that would make these guys the same. They have to be different. These are the two different hypotheses, ideas. So the HO is always equal. So therefore H1 can never be equal. It's got to be either greater, less, or not equal. How do you know which one it is? Well, you look for a key word. You look for a word like more. Does it say more? That'd be greater, or less, that'd be less, or bigger, smaller, higher, lower, something like that. Do you see any word like that up there? Now, if you look close, you'll notice it says right there, more likely, more likely. So that's going to be greater than, more likely, more likely. So there we go, more likely. Okay, so again, and how do we know what's the first group and what's the second group? Well, the first group is again those is right here. First is the group that is the couples that live together before they get married. And the second is those that do not. How do you know? You might wonder, well, how do you know which one's first, second? Well, it's literally just the order they come in the sentence. Let me finish this. Do not live together. Just take them in the order they come in the paragraph. See what it says. blah, 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 blah. Which one came first? Right here, live together. Our couples that live together. They just came first. So just make that group one. More likely compared to couples that live apart. So do not live together, live apart. So yeah, just take them in the order they come in the word problem. Whatever comes first, that's P1. Whatever comes second, that's P2. Okay. So the question is then, so the null hypothesis, HO, is, let me try that again. There we go. HO, that's saying, hey, the first group and the second group, they're equal. They're the same. What is the divorce rate? The divorce rate for the couples that live together before they get married and the couples that don't live together before they get married, it's equal. And that's what HO is saying. And the other attorney, H1, he's saying, no, 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 no. The first group is higher, more likely than the second group. The first group that live together, they have a higher, greater, right? Remember the wides, whatever's on the wide side's the bigger one. They're saying P1's greater than P2. The couples that live together have a higher divorce rate than the couples that don't live together. That's what H1's saying. Which one's right? Well, the calculator, we're going to throw the numbers in the calculator and it'll tell us which side has the data. Before we do that, though, I want to make sure you're clear. HO is always weak evidence. We only go with HO if evidence is weak. And H1 is always strong evidence. That's every hypothesis test. HO is weak evidence. H1 is strong evidence. So it's just like, to help you remember, it's just like a court of law. In a court of law, you start with HO, right? HO, zero before one. You start with HO, which is what? You're supposed to assume the person is innocent. In a criminal case, you're supposed to assume the person is innocent. And if the evidence presented is weak, if it's weak, you're going to stay with HO. You're going to stay with the assumption of innocence. That's exactly what we do in a hypothesis. If the evidence is weak, we're going to stay with HO. We're assuming HO is true. And if evidence is weak, we're going to stay with HO. But if evidence is strong, we're going to go with H1. Like you convict somebody. If evidence is, what's the law say? Beyond a reasonable doubt. Strong evidence. We'll go with H1. That's always the case. Every hypothesis test. All right, here we go. It's time to go to the calculator. We get the test statistic p-value. There's the answers. You see them. How do we get those? We got to go to the calculator. We're going to put in what? Well, we're going to put in these numbers, this 204, 673, 109, 454. How do you know where to go? Well, let me show you. Here's the notes. So here's the exam 4 notes. We're right here on number 1, 2 proportions, because that's what we have in this problem, right? We don't have means or averages. We don't have averages. There was no mention of the word average anywhere. It was, 204 of 673. That's what proportion, what part. And 109 of 454, that's what part, what proportion, what percentage. So when you have 2 proportions, you're going to use the online calculator, 2 proportions. That makes sense. And for the hypothesis test, as it says right here, for the hypothesis test, sorry, I'm kind of messing things up. There we go. We have P1 equals P2. That's what we put there. And for H1, it's greater, less, or not equal to P2. It says it right there. HO is always equal. H1 is greater, less, or not equal. We already did that. So we're going to put in the successes, X1 and X2, and total observations, N1 and 2, for both samples. Anyway, so let's go do that. We're going to go to 2 proportions. Okay. So I'm going to go to that calculator. There it is. So here's the different calculators. What 2 proportions is down? There's number 19. See it down there? I'll click on 2 proportions, number 19. It opens up. Okay. Now here it is. They want me to put in the stuff. Now, sample size and number of successes. Okay, so let's go back. And I'll just write it right here so we can see it really clearly. Okay, let's just get rid of this. And we're going to go to the 2 proportion calculator. 2 proportions. And we're going to, it says for the first group. Wait, I should have one more in there. We're going to have sample size and number of successes. And we're going to have first group and second group. Okay. So that's what it wants us to put in the calculator. So what's going to go in those spots? Well, What's the sample size for the first group? Here's the first group. 204, 673. So the 204 goes here. Out of 673 goes there. And 109 of 454, 109. Oops. 454. So remember, the sample size is always the bigger number, right? Bigger than, 673 is bigger than 204, 454 is bigger than 109. So, because 204, and what's success? Well, it's kind of weird, but they got divorced. That's certainly not success, but success it's kind of a weird word to calculate. It just means whatever you're measuring in the problem. In this problem, we're talking about how many couples got divorced, right? It says 204 of the 673 couples from the study who lived together before they got married were divorced within 5 years. So success is divorce. That's obviously not success, but you know what we mean. So 204 were divorced out of 673. For the first group, the live together group. This is a live together group. Remember, this second one is do not live together. Okay, anyway, so here we go. So those are the four numbers you put in to the two proportion calculator. And then what else do you got to put in? Well, there's also radio buttons that we need to put in. So let me write that for you. So there's some radio buttons. First one is I think probably pretty easy for you. We're going to do whatever is right there on H1. We're going to do greater. There's the first one. And I'll show you this on the notes. Let me show you right here. It says right down here for hypothesis test, choose P1 greater, lesser than or equal, matching H1. So whatever matches H1. So I just went there, boom. And I'll just say from H1. We just grab that from H1. That's what we always do. Now the other thing, here's the tricky part that I want to make sure you're clear on. The radio button pooled. Notice we're going to choose pooled. If you're doing a confidence interval, which we'll do on some other problems, you leave the radio button on not pooled. But we're doing a hypothesis test, you got to choose pooled. So for a hypothesis test, they're always pooled. All right, so we're going to choose pooled. All right, so if you go back and do that, let me show it. Okay, what were those numbers again? 673, 204. Come back here. 673, 204. And then I'll remember those ones. What was it? It was 454, 109. 54, 109. 4, 109. And then down here, I'm going to choose greater. See these radio buttons I'm going back and forth between over here? Going to go with greater. And then over here, pooled. See where I'm changing that? Pooled. So again, radio buttons over here, greater, radio buttons here, pooled. Then hit calculate. All right, there's our Z and our P that we carry. The Z and the P at the bottom there. Right here, I can make them bigger there. The Z and the P, those are the two numbers that wants back in the problem. There we go. Let's go back. And there they are. We've already got them. There's the P, there's the Z. Numbers, you put those in. Okay, now it's time to draw a conclusion. How do we draw our conclusion? Well, we put the p-value down and the alpha level down. Okay, what's our p-value? Well, it's right here. Came out 0.0102. You don't need that other zero in the front. I mean, put there if you want to. What's the alpha level? It says it up here. Alpha level 0.1, level of significance. 0.1. Now, it's easy to get tricked on that. Which one of those is bigger? Remember, this is 0.10 really, right? It's not 0.01. It's 0.10. So which one's bigger? Well, that one's bigger. Let me give it a different color. Right? 10, this one's bigger. 10 is certainly bigger than 1. But it's easy to make a mistake and think, oh, that's 0.1. It's not 0.1. It's 0.10. See where the decimal is? So which one's bigger? Remember, the bigger one goes on the wide side of the symbol. So this is bigger. So that means our p-value is less. All right. So anyway, Remember, and then what's the saying that helps us draw the conclusion? If the P is low, this is the saying you want to know. If the P is low, the HO, the null, must go, meaning go away. So that's the little rhyme. If the P is low, the null must go. If the P is low, the null must go. So is our p-value low? Yeah, it's less. See, the p-value is less. So yeah, that's definitely low. So the p definitely is low. What does that mean? HO, the null must go away. What does that mean? We're going to reject right here. We're going to reject HO. Because the HO, the null, must go away. If the P is low, it's less. If the P is low, the null must go away. You must reject the null. Reject the null. It's going away. Okay, now you think, well, a lot of students ask me, hey, Mr. I don't know how to do these last two, how to do those. Well, it's all about, remember, this whole hypothesis test where HO and H1 are arguing. They're like two attorneys in a court of law. One of them saying innocent, the other one saying guilty. And we threw the numbers in the calculator, and the calculator is going to tell us by way of the p-value which side has the evidence. What did it say? It said reject HO. Well, if we're rejecting HO, let's come back down here. If we're rejecting HO, then we must be keeping H1, right? If you're saying no, no, no to HO, you're rejecting HO, then you must be keeping H1, right? So come up here. We're going to reject HO, bye-bye HO, and we're keeping H1, this one. This is the one we're keeping. So what does he say? He says strong evidence, and he says P1 is greater than P2. So we just write that down. We're keeping that one. He says strong evidence, and P1 is greater than P2. That's what he says. I just simply, so again, how did I do that? So right here, I said, here's the saying that helps us every time. If the P is low, the null must go. Our P was low. It was less. So the null must go away. Reject the null. If you're rejecting the null, then you're keeping H1. Remember, you're gonna get rid of one of these and keep the other. It's just a matter of which one. Well, how do you know? It said if the P is low, the null must go away. So I reject the null. Therefore, I'm keeping H1, and just go, okay. So keeping H1 is the one I'm keeping. This is the one I'm keeping. I'm rejecting the null, but I'm keeping H1. What does H1 say? Strong evidence. P1 is greater than P2. So that's what I believe. That's what the evidence tells me, not just my belief without evidence. It's what the evidence is saying. It's strong evidence that P1 is greater than P2. Strong evidence, and as we say down here, greater. See, this is the greater. P1 is greater. P1 greater than P2. P1 greater than P2, right? That's what that symbol means. Greater. And what was the P1 group again? Right up here. P1 is the live together, and the P2 is do not live together. So the live together, the divorce rate is greater than the P2, which do not live. The divorce rate for those who do not live together before they get married. So there's strong evidence, at least in this case, based on this study, excuse me, based on the numbers we looked at, there's strong evidence, as it says here. So our conclusion is that the likelihood of getting divorced within 5 years of marriage for couples that live together before they get married is greater than the likelihood of getting divorced for couples that don't live together, live apart before they get married. Greater. It's greater. That's what the evidence tells us. And you can see that in the numbers, right? 204 out of 673 were divorced. That's almost a third. Whereas for those who didn't live together, it's like a fourth or a fifth. It's less. So there we go.